In this video, we are going to solve one fascinating question concerning equality of the determinant of two matrices. Here is the question. If the determinant of this 3 by 3 matrix is equal to the determinant of this 3 by 3 matrix, find the value or values of x. If this equality had stood for two matrices, we would have solved the value or values of x simply by equating the corresponding elements of the two matrices. But the mathematical notion here is different because determinant stands for a single quantity obtained by addition of the product of elements of a square matrix by following certain rules. So, to find the value or values of x, we have to calculate the determinant of both matrices and then equate them. The determinant of this left-hand side matrix equal to find the determinant of 3 by 3 matrix, we have to express the given matrix as the sum of 3 2 by 2 matrices by taking one row or one column of the matrix as the coefficient of the 2 by 2 matrix we are going to form. In order to shorten the steps we are going through, it's advisable to choose a row or column containing more zeros. For this particular case, let's choose row 3 as a coefficient because it contains 1 0 and no row or column contains more than 1 0. After choosing a row to be used as the coefficient, our next task is to assign the sign of the coefficient because their sign alternates between positive and negative depending on the row or column where the coefficient is found. The simple rule for such assignment is to make positive sign for row 1 column 1 entry, negative sign for row 2 column 1 entry, and positive sign for row 3 column 1 entry down column 1. Once we find the sign of the first element of the row we choose as the coefficient, we can make negative and positive signs alternatively across a row. The first element chosen as a coefficient is 0, so no need to include it in the calculation because 0 times any number is 0 and adding 0 to any number doesn't change the final result. The second element is 1 with negative sign, thus minus 1 times the determinant of the second 2 by 2 matrix. Let's form the summation first and then we will find the matrix elements. The third element is 2 with positive sign, thus plus 2 times the determinant of the third 2 by 2 matrix. To find the elements of the 2 by 2 matrix, we have to cross out the row and column where the coefficient is found. This one is in row 3 column 2. Crossing them out left us with 1 and 4 in both row 1 and row 2 of the 2 by 2 matrix. This 2 is in row 3 column 3. Removing row 3 and column 3 gives us these 4 elements, which is equal to negative 1 times. To find the determinant of the 2 by 2 matrix, we have to multiply main diagonal elements, and from that product, we have to subtract the product of the remaining 2 elements, 1 times 4 minus 1 times 4, plus 2 times 1 times x plus 7 minus 1 times 2x, which is equal to negative 1 times 4 is 4, minus 1 times 4 is again 4, 4 minus 4 gives us 0, plus 2 times 1 times x plus 7 is x plus 7, minus 1 times 2x is 2x, which is equal to negative 1 times 0 is 0, 2 times 7, x minus 2x is minus x, which is equal to these two outside the bracket multiplies each element inside the bracket. 2 times 7 is 14 minus 2 times x is 2x. So this is the determinant of the first 3 by 3 matrix. To find the determinant of this right hand side matrix, let's choose row 1 elements as the coefficient and assign their signs as positive, negative, and positive. The first coefficient is 0, so no need to include it in the calculation. The second coefficient is 2 with negative sign, thus minus 2 times the determinant of the second 2 by 2 matrix. The third coefficient is negative 1 with positive sign. Negative times positive gives us negative. That's minus 1 times the determinant of the third 2 by 2 matrix. This 2 is in row 1, column 2. Removing them gives us x squared 2 in the first row of the 2 by 2 matrix and 1 negative 3 in the second row of the matrix. This negative 1 is in row 1, column 3. Crossing them out gives us x squared 2x plus 1 in the first row of the 2 by 2 matrix, 1 in the second row of the matrix. This is equal to negative 2 times x squared times negative 3 minus 1 times 2 minus 1 times x squared times 1 minus 1 times 2x plus 1, which is equal to negative 2 times x squared times negative 3 is negative 3x squared minus 1 times 2 is 2 minus 1 times x squared times 1 is x squared. Negative 1 times 2x is minus 2x. Negative 1 times 1 is minus 1, which is equal to negative 2 times negative 3x squared is 6x squared. Negative 2 times negative 2 is plus 4. Negative 1 times x squared is minus x squared. Negative 1 times negative 2x is plus 2x. Negative 1 times negative 1 is plus 1, which is equal to 6x squared minus x squared gives us 5x squared plus 2x plus 4 plus 1 is 5. So this is the determinant of the second 2 by 2 matrix. It's given that the determinant of the two matrices are equal. In other words, these two results we found are equal, meaning 5x squared plus 2x plus 5 equal to 14 minus 2x. This implies, let's collect like terms, 5x squared plus 2x. When we bring minus 2x to the left of equality sign, it becomes plus 2x plus 5. When we bring 14 to the left of equality sign, it becomes minus 14. Nothing is left to the right of equality sign, so it's equal to 0. This implies 5x squared. 2x plus 2x gives us plus 4x. 5 minus 14 gives us minus 9 equal to 0. To solve this quadratic equation, we have to find two numbers whose sum is equal to 4, which is the coefficient of x, and whose product equal to negative 45, which is the product of the coefficient of x squared, that's 5, and the constant term, that's negative 9. These two numbers are 9 and negative 5, because 9 plus negative 5 gives us 4, and 9 times negative 5 gives us negative 45. Then we have to write this 4x as the sum of these two numbers, meaning we have to replace this 4x by 9x minus 5x or negative 5x plus 9x. So let's rewrite the equation. That's 5x squared plus 4x means minus 5x plus 9x minus 9 equal to 0. The common factor for 5x squared minus 5x is 5x times 5x squared divided by 5x gives us x minus 5x divided by 5x gives us 1 plus the common factor for 9x minus 9 is 9 times 9x divided by 9 gives us x minus 9 divided by 9 equal to 1, which is equal to 0. X minus 1 is a common factor for both expressions. So taking it as a common factor, we will find x minus 1 times 5x times x minus 1 divided by x minus 1 gives us 5x plus 9 times x minus 1 divided by x minus 1 gives us 9, which is equal to 0. This expression equal to 0 only when either x minus 1 equal to 0 or 5x plus 9 equal to 0, because it is the product of the two terms. If either of them equal to 0, the whole product will be 0. X minus 1 equal to 0 only when x equal to 1. To solve for 5x plus 9 equal to 0, take plus 9 to the right of equality sign and divide both sides by the coefficient of x, that's 5. Then we will find x equal to negative 9 over 5. If we substitute either of these values in place of x and solve for the determinant, we will find equal result. That's all for this part. Bye bye.